Hi, this is Dr. Rami. Today I'm going to talk about digital implementation and application, how to build your digital twin step by step. First, I would like to thank TEDra Virtual Academy for such opportunity to discuss and explain the biggest milestones in terms of the 8 future management tools technologies. And now we are talking about one of these most important and essential technology, which is digital twinning. First, allow me to introduce myself. My name is Dr. Rami Shaheen. I'm international subject matter expert who work closely with international organizations using artificial intelligence and future management tools. The only consultant who's part of the global AI index, in where we indexing most of the countries in terms of utilizing the artificial intelligence and other future management tools. Have three registered inventions in technology, work closely in country transformation level in UAE, KSA, Jordan, Egypt, Bahrain, Japan, Denmark, UK, Turkey, and some other countries. Develop different solutions in digital twinning, including the manufacturing and military industry or use cases. Have been involved in putting the standards for digital twinning, either for manufacturing, for smart city, for some other implementations. Awarded as the most influential consultants in Middle East for AI and future management tools. I highly recommend to read my book AI and Future Management Tools Between Emerging Opportunities and Technologies. Now, let's start our journey and talk about the expected cognitive accomplishment after having this short session. We'll talk about the requirement of building digital twin, and it's very important for us. What we need, and most of the organizations around the world, they struggle in identifying the required for their entity, uh, for their organization, for their even project to move along with digital twinning. We'll talk about how to build the capability required for organization in order to have a proper digital twinning for their organizations. Then we'll talk about how to accelerate such development and implementation of digital twinning. And we'll have a very short use case on telecommunication industry. Let's start. First, we need to understand that building digital twin is always counting on the capabilities that are required to be achieved in your organization in order to be able to implement digital twinning in general. Now, for each and every single part of your organization, there is a set of capabilities and competencies that require to be achieved in your organization in order to be able to develop and implement digital twinning in your organization. These capabilities will always determine the objectives, the combination between people, technology, and data. And that's what we explained in our previous course. And I highly recommend you guys to read about, to watch it. Digital twin not only require a set of capabilities, but digital twin as well will compose a number of technical competencies to provide an overall solution that will be focused on getting certain competitive advantage for your organization or your product. By the way, technology is not a competency, it's a capability. It's not a competency or a capability. It's a set of technology based integrated solutions that will be required in order to achieve the competent digital twin. So, the competency table that we're going to discuss is focusing on the technology based capabilities, but is agnostic to specific technology or and solutions. Capability, as we discussed, is not the technology. So capability is the ability to perform certain actions or achieve certain outcomes from utilizing this technology. The ability to drill through or drill a hole is a simple example of capabilities. There are multiple use cases that requires holes, and each of them will have a unique requirement in terms of the size, the depth, and or the substance that is drilled. This may be one of the main capabilities required to complete a project where the whole is part of successful. The CPT, the capability of digital twinning, is focusing on the technology based capabilities, but it's agnostic to a specific technology or a product or a solution, as we discussed. We need to remember these points, guys. So when we start implementing, we will understand exactly what's required. So let's talk about what is required. So we need to assess our stakeholders' capability, our own capabilities, in order to fulfill this technology capable requirement in a one use cases that in a one use case that will be beneficial for our organization. So let's talk about how we can get this capability done. For sure, we all know that we are living in the revolution of technology, and the digital twin competency periodic table, we call it the CPT, is one of the revolutionized architecture and technology that agnostic the requirement definition framework required for digital twinning. Its main uh, results will be design, develop, and deploy the operating digital twin based on different use cases and based on different capability and requirements in the technology itself. So we need to know what parts we have for this CPT. We have the data service where we can describe whatever required in the design, develop, and deploy for our operating digital twin relating to the data service. Then we start talking about the integration part in order to build an integratable digital twin solution in each and every phase of it. Then we're gonna build the intelligence of our digital twin, which will lead us to have a proper management for our different artifacts and capabilities in our organization. Having these components all together will help us to build the use cases, or we call it the UX, user experience of the digital twin, which will lead us to achieve the required results for our digital twinning and extract the required information and drill through a proper need of what is required from our digital twin. For sure, we know that these technology need a level of trustworthiness. So we build a set of artifacts that will help the organization implement the digital twin with a proper trustworthiness artifacts that will optimize and enhance the security, trust, and confidentiality level of your digital twin. As you can see, the CPT is being implemented in different organizations around the world, starting from Dell, Microsoft, Autodesk, Johnson Controls, and many others. Now, let's talk about the architecture itself. What we are doing. As you can see, from bottom to top, we'll start having our own source of data, our own metadata in a place, our own derived or compound data extracted in a one data fabric. In addition to the processes, model repositories, and all logs for any transaction that will take place, all these things will be saved in one data fabric. Then the technology service will be composable business capability that will extract these data fabrics in a proper manner to have a physics-based model, analytical model, IoT, transactional data, visual model, and master data. All these technology services will be aligned with main capabilities. These capabilities will take the technology agnostic requirement to a framework that will be identified through the CPT and will optimize, enhance, and align whatever required for us to build our own digital twin. will always consider two main factors. And by the way, guys, the most of the challenges are extracting from identifying the legacy business and IT application and OT application. And it's very essential and important to identify the IT and OT. Once you have all these things together in your architecture, will be able to build a digital twin composition platform where you integrate, orchestrate, develop, and have the UX development, which is a main capability in the CPT, by the way. All these things will allow us to compose more than one digital twin together, and it's possible in organizations to compose digital twin together into one system to help us build the required maintenance, optimization, and monitoring for all these digital twin to achieve the required result. Digital twin systems transform business by accelerating holistic understanding, optimal decision making, and effective actions into a real time cases with a real time representation of what going on, what happened in the past, and what we are doing in the present, to simulate a set of a prediction as we discussed before, in the future. By the way, the main motive of having a digital twin is the outcome. We need to tailor our use cases and power it by integration and build data that is valuable for our business with a proper valuation, with a proper ROI, which has I've been explained about it in my book. How to build a valuation for your data. For in particular, when you deal with digital twin, you need to have a full valuable data that will benefit the digital twin DNA in general. All these things need to be guided by a domain knowledge and implementation, as we said, in IT and OT in general. So we need a consistent framework to identify all these capabilities that can be grouped together to create what we call it the competencies and capabilities of our digital twin. Or you can you can achieve with it a composable digital twin model that will outline the different data types and data sources that are leveraged by the digital twin to create a reusable and agile digital twin composition. By the way, the composable digital twins is an application development approach for digital twin that is based on the composable enterprise architecture pattern. Composable applications such as CDTS focus on the faster time to value service based orchestrator and reusing package business capability to develop and adapt application as a business requirement evolve. Packaged business competency are a modular combination of technical capability that are presented as a bundle services. All these digital twin are orchestrated together through an application composition platform to deliver digital twin application for any specific use cases that will come to you. This point is very important. So we need to sum up this slide to say that we need to build these capabilities in a different way and different manner with the same or common competencies that will achieve what is required for us in our organization to enhance the outcomes with the clear value definition and clear integratable manners of such artifacts or competencies or capabilities for your organization. Now, there is a question about digital twin implementation when we talk about each and every artifact working either with the edge controllers or with cloud optimization. What is digital twin? As we said, what is the component and characteristics of our digital twin? What is the use cases? I need to have it in my library. Describe the application benefits either in each and every cluster of the organization or in each and every set of departments in your organization. which help us to get started to manage our systematic approach that we've been discussing for a while, uh, in order to optimize these capabilities and align them together to achieve the required result that will facilitate a collaboration in multidisciplinary fusion teams with requirements and specifications. Now, let's talk at the capability of the life cycle for each and every part of the CPT. If we start from the bottom of the screen, we can see that each and every capability is identified with the CPT, and each part, like data management, UX, whatever we discussed earlier, is clustered and divided into different artifacts. Each artifact will be managed in order and optimized in order to implement the digital twinning in a proper way. At the end of this slides, I'll show you a telecommunication case study and how we identify the artifact and break it down in order to have a proper results for our digital twin. As you can see, the systems, sensors, and services will always be there as identified sources of our system. These identified sources will always provide us with a full and understandable data, with a clear metadata that will master the data models in general and with the transactional business systems. All these things will work together to take us to the typical data model, starting from clustering data into customer data, demand data, classified plan items, operational data, behavioral data, historical fault data, for example, operational data. All these data will come along together with a twin life cycle to starting from as we plan it, as as is we design it, as is we construct it, as is we commission it, as is we operate and maintain it, as to retired. Then we'll go directly to the capability layer where we cluster all these requirements in a very clear manner across the full life cycle of the digital twin. The capability, by the way, may differ during the different phases, but identifying the key capabilities for each phase remain the same throughout the whole life cycle. And this is very important point. Some capability might transfer between life cycle phases, other may become obsolete, and other may be added to the capabilities. Capabilities during the design and construction, for example, phase may not all transfer to the operation and maintenance of a certain organization. This facilities and the developments of the digital thread as it transition through the different life cycle phases. And we all know how building these shifted capabilities between artifacts or between phases is very important. uh, the period the CPT is here will play a vital role, as it can also be used to identify the capability of the digital thread itself, and it's very beneficial to identify whatever you implement in the capabilities of your digital twin, you and you do the same on the digital thread level, which will give a consistency approach for increasing the capability, the overall capability maturity, basically, and for both the digital thread and the digital twin on different organizational level through the full product life cycle. All these things will help us to identify and build different use cases. These use cases will all be measurable, tangible, and will be easy to implement and debrief the organization use cases using the digital twin with the realistic outcomes. These capabilities, guys, always give you a realistic outcome of your digital twin. And this is one of the main challenges that the organization face when they build their own digital twin. Sometimes they have a nice UX, but the feeding of data is not reaching the required level of maturity. So sometimes they do the drill through, or they do the feeding of information manually, and this is very risky, by the way. So once you build the capabilities with this structural life cycle, we'll make sure that we don't need to feed the system anymore manually with whatever data we have. We'll make sure that we have a realistic KPI that will build and help and support each use cases in your organization, and will fine tune our results and outcomes in a proper way that will help the organization and the modulation of construction and the compliance and the verification process and the production optimization, production simulation, safety, health and safety, the disposal of classified assets. All these things will help again and will be reflected on the assets, the system, and the process. If you will be able to achieve your digital twin and digital thread objectives with such capabilities on these three layers, then you have a mature and a proper functioned digital twin. And this is very important point for us when we start working on digital twinning in general. Why? Because in this life cycle, we are trying to achieve such result through making sure that we have a proper set of data that will help us to reach the direct data clustering and analysis, will help us to visualize the model and the systems in a proper way, and will have a proper transaction management and incidents management in our organization. So if you want, for example, to implement any ISO standards on these transactions or on these clusters, you will be able to have it as a result of a reflection from you for your digital twin on systems, for example. All these things will achieve a proper management, as we discussed. Achieving a proper management is not related only, and that's what most of the people think, that managing the digital twin is not about what's going on in the digital twin only. It's as well as how the digital twin is helping other departments or other related stakeholders or entities to optimize their performance with a level of trustworthiness. And this trustworthiness is between stakeholders, and it's between entities, it's between organizations. So, in order to do so, you need to have a clear process with a clear set of capabilities identified in your organization, and help you to achieve the required result in all level of or in all phases of the life cycle. Now, we need to know that each artifact in this periodic table will identify to us a set of capability. These capabilities will be identified by what it is, what type we have from it, a description about it, and it's very important. Sometimes in the digital re-engineering phase, or even digital connectivity phase, we face some challenges while we implement digital twin for organization, that the capability itself is not clear for the organizations or for employees in the organization, and it might create some set of delusion for such things. So so we need to explain and have a descriptive analysis of what is the capability type for the organization, and that will be clearly mentioned in the digital twin periodic table. The outcome and purpose, why we want to have such capability, for example, edge AI and intelligence, to make a real-time decision in the field, or so on and so on. The other thing is the clustering. How we gonna cluster this particular capability? Is it a core? Is it enhancement of the system, or it is specialized for a special set of assets or systems or processes? So we need to identify each and every artifact or each and every box in our periodic table related to one category of the periodic table. Once we have all these things, we need to make sure that we understand the capability description that we have in general for our organization. So, as we said before, we have the data service, we have the integration, we have the intelligence, we have the UX, we have the management, and we have the trustworthiness. Six components, main components. Each component will be determined and will be having a subclusters or sub artifacts that will identify the capability of this particular category. Okay, so for example, data service, it will enable data access, ingestions, and data management. It's anything related to data will be in one place, either from edge to a data center in general. It will establish the connection that we already explained in our previous course, the connection between virtual pillar and physical pillar in particular, which will direct the data, equipment, sensors, controllers, even the platforms to process and distribute per tier or per pillar. Okay, so the data service here is very important to identify the definition, or I understand the definition of it. Integration is enabling the data access, and this is a very important challenge between organizations or companies who got sub companies under them, so or many sister companies. We need to enable the access level to the internal and external enterprise system in general, and application to enable communication among different digital twins in different company. And again, it will consisted of different artifacts or subcategories that we need to consider, identify for our organization. Intelligence, we provide an environment for development and deployment of industrial digital twin solution in particular, or any cognitive digital twin solution that we need to explain and discuss. We provide integration by basic and advanced analytics in general, or by providing a smart big data as a layer of that, with a proper orchestrator with a hyper intelligence or RPA or so on, and other processes capabilities. And this part is very important to integrate other future management tools such as smart big data, AI, RPA, and so on with your digital twin, and it will always provide the capability to do so. We don't forget that provide the user with the ability to interact with each and every part and artifact of the digital twin is very important. In addition to visualize the data in a proper way that is understandable for us is very important as well. So we need to have a clear UX. In our periodic table, we identify how you can identify the subcomponents of this table, and how it will be reflected on the performance of the data extracted, for example, or the performance of integration, or the intelligence part of it. And we not forget managing everything need to be majored in a proper way. So whatever you major, you can manage. So you need an ecosystem management of this capability. And here we build a set of artifacts that will identify these artifacts in general and manage between them. Trustworthiness, we are talking about a very important part that taking place these days, especially while we start thinking about integrating different pillars for emission and so on. We're gonna discuss the trustworthiness from different perspective, from security. So we need to have a secure security layer on top of our system. We need to have the privacy between each and every entity if we have more than one industrial digital twin that is connected to each other. The reliability and resilience capability of our system, this is very important and essential part. And here we might talk about having a hyper intelligence on or RPA on top of the digital twin or cognitive digital twin to achieve the resilience capability for our digital twin in general. As we can see, here is the sub competencies for each and every category that we already discussed. We have here a full framework. We might use some of these subcategories, and we might use all of them. It depends on different levels and different requirements we have, and the type of digital twin that we are trying to build. Either it's a general digital twin, or common, or we having as a cognitive digital twin. So the requirement of the use cases will determine the deployment environment for the different capabilities that address these use cases. Some use cases might require digital twin competencies at the IoT edge, while other may require processing, for example, in the data center, and some instance hybrid deployment models may be needed. Some others they might not need such a thing. The digital twin capability specifications must consider the various deployment requirements that we have in our organization. As you can see, for example, just to imagine the whole story. For example, we need a model repository. We need for our data and archiving services. We need a simulation model repository. We need AI model repositories, and this is very important for organization. For example, in telecommunication or oil and gas, or what we call it the critical industries, they need to have a repository for the AI model in order to connect it to what we call the experimentation, or the experimentation will be related to a team of people called A to F team, and they are qualified team having idle certificate, international artificial intelligence and future management tools driving license. Uh, uh, Through this team, they will be to experiment different level of AI models on the digital twin, which will help later on the production and the preciseness and the resilience of your digital model. Then we'll go to the integration part. We'll give some example like OT and IoT system integrations, the collab platform integration, API services required for such integration. All these things will come along on the integration part to discuss it and to have a proper description from the model itself, and it's available to each and every sub-pillar here in the competency model. Then we're gonna go to the third part. We're gonna start talking about the edge AI, reporting, simulations, mathematical analytics, composition between VR, AR, and digital twin, the business rules, if there is any, the health and safety rules and compliances, if there is any prospective recommendation. Usually we got it. Then we're gonna move to the other pillar, which talk about the business intelligence, real time monitoring, entity relationship visualization, as again a virtual reality component to show such a thing. The gamification part can be reflected on the digital twin, and it's very important. In general, it will take us to another part, which is the management, where we're gonna start talking about the device management, the logging. It's very important to have a clear logging, which will always help us do the tracing of digital twin activities. For sure, we'll not forget the data governance, and it's part of the management part. Usually some people took it to the intelligence part, and they do this mistake, which will always result what we call it the blind spot of our solution in general. Data governance and the solution governance will always be compromised of four main parts: operationalization, level of involvement, internal structure and measures, and stakeholder communication. All these things will work together to have a proper management on the system monitoring level, which will be again protected by a set of security, privacy, a resilient and reliable systems that will make sure that the system achieving the required security and trustworthiness required in general for our system in general. If we'll be able to build such technology with such artifacts or sub pillars, we'll be able to, and we identified clearly, we'll be able to have this layer that we already added to our life cycle, that will smoothen the work, build up on the use cases, and will enhance the overall continuous intelligence of your digital twin to reach what we call it the cognitive digital twin. As you can see here, we are dealing with the capabilities and artifacts. We're having a case study for the telecommunication industry. As you can see, the digital twin capability of data artifact is identified here. We identified the data acquisition and ingestions, the data streaming, data transformation, where the first a few column present the static information about the capabilities of the cognitive digital twin, and the column marked as you can see on the right I represent the specific requirement of this particular use case. This for illustrative purposes, and it always vary on a specific application of the cognitive digital twin for the end user and the user data acquisition, ingestions capability requirements, and dealing for real time sensor reading with high frequency and low latency. For example, in our case, the specific requirement is 15 tags at a 5 seconds frequency with a 10 kilobyte payload. Where we are building this use case, it's always state the capabilities is needed at the edge with potential use in a data center environment as well. So, for example, data streaming is identified here with the data service is a main pillar that we already explained and discussed, which is the ability to transfer a large volume of data continuously. And incrementally between source and destination without having to access all data at the same time. And here we identified as an ability what it means. We identify the purpose of it. The purpose is acquire a fast continuous packet of our information which is changing at a high speed to be able to get near real time insights. All these definitions is already there with the CPT and with the periodic table to build the cognitive digital twin, and then it will be aligned and specified with the use case that we are trying to implement on it, which will create a definition for each and every level that suit to the capability maturity management in the organization. Periodic table clearly show overlapping capabilities as well as unique requirements that are only applicable for a specific applications. And we need to be clear about this, guys. When we start talking about the capability, it wasn't clear in our head. Then we start building a clusters. Then we identify these clusters. Then we build these clusters with a clear workflow. Then we have these sub pillars or sub components identified, as you can see here, to provide an overall workflow process together, working and communicating to identify a requirement for internal stakeholder as well as external stakeholders to have a solution that will be identified clearly to take it from only a normal digital twin to a cognitive digital twin. For sure, in our case for telecommunication, we are taking each and every part of the main pillars that we already explained, and we are having the full ability, full purpose identification. Then we try to implement it on the capability requirement as per the use cases, which will give us a clear identification of all the capabilities, and it will take our digital twin to the next level, which is the cognitive digital twin. In our case, after we identify all the main capabilities, we realize that, for example, we need the data acquisition, data streaming, data transformation, data contextualization, real-time processing, and so on. And there is some missing part, as you can see, that is not there in our digital twin, which means currently the cognitive digital twin will not require these particular sub pillars, and will not work on it, will not waste our time on it, will not waste our resources and investment on it. And usually this is happening in organization that when they build digital twin, they start implementing each and everything in one go, and they lose time, investment, and overlapping of efforts. Digital twin need to be targeted with a clear purposes, and that what we are doing here with a cognitive digital twinning table. With such capabilities here, we'll realize that telecommunication industry will require these capabilities with a clear action plan, as you saw in the previous slide, identified and assigned to the A to F team, or the transformation team, the team or the task force team, if you allow me to say that, who are responsible to build such digital twin and enhance it, optimize it in different level of the organization and in different layer of the organization, which will help us to overcome any blind spot in the information layer or in the business layer in general, and it will minimize the technology layer to the edge, which will help us to take it step by step later on to optimize and achieve the best result in digital twin in general. I want to talk about digital twin in general. Use digital twin for collaboration and common understanding will help us to build a proper use case. And we saw that building a use case is the last layer of having a digital twin. Before that, we have a set of actions that we need to take it in order to build the digital twin, which will help us to build the capability requirement and provide a solutions, a real-time solutions for us in general. Building a digital twin competency will accelerate transformation by nature to reflect it on a real time and reflect it with a clear results that we are looking for. Digital twin may drive a tangible value for companies, create a new revenue stream, and will help always to answer key strategic questions with a new technology capability that have a high level of flexibility, agility, and lowering the cost of company for sure. Maybe able maybe the enablement of the starting journey for having or creating a digital twin with and that's what we try to achieve here, with the lowest capital investment and a shorter time to value than ever before. So that's what we're trying to achieve. We are trying to achieve, and what we try to explain here, that we can achieve through the periodic table of digital twin. As you know, that the digital twin have many use cases, many application around the life cycle that may answer any challenges or sort out any challenges in a real time manner. And show you some blind spot, as we explained earlier, that you never saw in your organization, to provide the kind of value consideration near inconceivable just a few years ago, as you all know, in your businesses. So perhaps the question now, whether we should get started now with a periodic table building the capabilities of our organization to get the biggest value in the shortest time and amount of ahead, and how we can stay ahead always of the competition, by having and building not only a digital twin. We will build a cognitive digital twin, which is an integration between different pillars and parts of your organization, of different pillars and parts of your technologies, such as RPA, AI, and smart big data, and some others, which will be taking the organization into the next step. On the same hand, we'll achieve this with the lowest investment possible and the highest time to value results. But the journey starts with a single step. I hope our single step will start today. Now let's revise quickly what we discussed. We discussed the overall view of the capabilities. We differentiate technology as a technology enabled pillar that will be considered as a small part of the capabilities for digital twinning implementation. Then we identify what kind of autonomy for our capabilities. Then we discussed the main parts, the main six parts of any cognitive digital twin, and we explained the life cycle of implementing digital twin in general, or cognitive digital twin. The whole story was were about cognitive digital twinning, which is the next level of digital twinning. And then we explained how each and every part will be identified with a clear purpose and a clear differentiation related to your use cases or your industry. Then we break it down into sub pillars. We identify these sub pillars to have a wrapped up plan, a proper plan, reliable plan for our organization. And then we got when we discussed how these competencies will be reflected on our organization in general, and what's the difference between other methodology and having this methodology in achieving cognitive digital twin in general. I would like to thank you for your precious time granted to me. Hope I was up to your expectations in terms of building and enhancing digital cognitive digital twin solutions. I would like to indeed draw my appreciation and thank Tedra Virtual Academy again for such amazing opportunity. And please don't hesitate to contact us for any further questions about how to build a cognitive digital twin step by step. In general, thanks for your time and hope you a good day.